All right, cool. So hi, everyone. Thanks for coming out. Looks like this was a rather popular session, which I'm happy about. I'm DB, or David, whatever you prefer to call me. And if you're here, I'm assuming that you're here because you want to learn more about how to do more advanced Git things. Now, advanced is a relative term, and there we go. If you're here, I'm assuming that you already know how to do these things with Git. You know how to clone a repository, you know how to check out and switch between various different branches, and after you've edited files, you can make commits, and you can push and pull those commits, and maybe do pull requests or something on GitHub. That is all you need to know. That is what I consider to be the basics. There's a lot more that we're going to cover in this talk, and this talk doesn't even cover everything about Git, but that's sort of like all you need to know to get started. So to start off, I'm going to introduce some visual terminology in this talk. This is a representation of a Git repository. You can see that this repository has a bunch of different commits on two different branches. One of those branches is called master. The other one is called feature. First thing to note right off the bat, branches in Git are not like an actual thing. They're more like a pointer. So when you think of a branch, it's really a pointer that points to a specific commit at a moment in time. So that's how you can see that there are two different branches here. There's a master pointer that's pointing to commit F in this case, and there's a feature pointer that's pointing to commit I right now. Does all of that more or less make sense? We have, this is all one repository with lots of different commits. So we're going to go over a bunch of stuff. This is all the various things we're going to go over. So let's dive in and get started. The first command that I always like to go over is git status, which is my favorite Git command. It's my favorite because it's always, always useful. It never screws anything up. It just gives you information about what the status is of your Git repository. So here's an example of running git status, and you can see there's not anything very interesting going on. Here's a more interesting case of running git status. In this case, status is telling us three things. There's a file that's been removed, there's a file that's been modified, and there's a file that hasn't yet been added to the repository. So you can see that there are these three different sections, and each section is going to have a list of files in there. And it even has syntax highlighting set up by default so that you can get a better idea of what you're looking at. I'm going over these things because although a lot of people have used Git before, not everybody uses it on the command line. Some people use the GUI, so this is sort of a basic review. So yeah, all that show does is it tells you what's going on in your repository. It's never going to screw anything up. It's never going to modify anything. It's always safe to run. So if you're ever unsure, git status is the first thing you should do. The next thing I want to go over is another command called git show. Now git show is a command that's used to get more detailed information about a commit. There's a bunch of things that you can see here. At the very top, there's a line that says commit and has a really long jumble of letters and numbers. That is called a commit hash. And the commit hash is a unique identifier for a commit. Every single commit in your repository is going to have a different hash. And in fact, these things are so long and so random that every single repository in the world, no two commits in any repositories are going to share the same commit hash. The chances of them doing so is astronomically small. So you can be fairly certain that if you have a 40-character commit hash, that uniquely identifies this particular commit and no other commit in the entire world, ever. You also have some metadata. You have the author information, when the commit was made. You have the commit message, and underneath that, you have the diff that you've probably seen before. Lines that start with nothing are just context. Lines that start with a minus are lines that were removed. It starts with a plus sign, then it's been added. And we'll get to more information about git show later on as well. So that's the preface. Let's dive right in and do some more advanced Git commands. How many have you have ever been in this situation? There's something going on. I don't know what it is. Tell me who to ask in my company so I understand what's going on. So git blame will give you the answer. What git blame does is when you run it, it'll find for every single line in the file the last person who edited that file. And it'll tell you the commit hash where it was edited, the author's name, and the date of the commit. And with git show, you can actually pass the hash to git show to get more information about that particular commit. Now what we're doing right here with this instance of git show is you can see we're using an abbreviated form of the hash. You saw that a normal Git hash has 40 characters, but in this case, we're only doing 7 or 8. Now, the reason for that is because if you provide only an abbreviated hash, Git is smart enough to look up all of the different commits that it knows about in its repository and see if there's more than one that starts with those characters. And if there's only one, it knows that that's the one you're looking for. And these things are random enough that usually you only need, at most 7 or 8 characters to uniquely identify a commit in your repository. So when I run git show followed by that short hash, it knows, okay, I want to look up this specific commit. And when you run it, it's going to look something like this, which is a bit overwhelming because it's showing you the entire file and all the metadata. So let me just bring up the first 5 lines, which are broken apart into 2 sections. These are actually one line all the way across. You can see first it's showing you the shortened commit hash for the commit where that line was changed. Then it's showing you the file as it's noted in that commit, followed by the name of the person who made that change, followed by the date of the change, followed by the line number, followed by the actual content of the file. So what that means is, if you know that there's some sort of problem in this file that happens on line 3, in this case, I know, oh, I need to talk to Ned Batchelder. So he's the guy who was the person to most recently make a change to this file. So you can combine blame and show to find out what happened at what point in time for every single line in every single file, which is pretty cool. So next, we're done with blame. We're going to move on to cherry pick. How many have ever been in this situation before? I accidentally committed to the wrong branch. Maybe I made it on master. I need to make a new feature branch. How do I move my commit? So what cherry pick does is cherry pick takes a commit and makes a copy of it onto a different branch that you specify. So here's an example to solve that problem that we just looked at. You can use git show to find the commit hash of the commit that you're currently sitting on. So if you don't provide a commit hash when you run git show, it's going to default to whatever commit you're currently sitting on. So if you're on master, it's going to be the latest commit on master, and so on. And you saw that the very first line of git show tells you that commit hash. Then we can use git checkout to switch to the branch where we actually wanted that commit to go. And then you can run git cherry pick and pass that commit hash. Or in this case, I'm only doing the first few characters, but you can do the whole thing if you want to. And that is going to create a new commit that is an exact copy of the commit that you have referenced using that commit message. So in essence, the graph now looks like this. We've created a new commit. We've started from J and we created J prime, which is now on the feature branch. And the feature pointer has been updated to point to that new commit as well, which is why the branch appears to have that commit in there. It's important to note that cherry pick does not delete the original commit. It's not a destructive operation. It's only going to create new things. So this is another command that you can run with confidence, knowing that it's not going to remove anything, it's not going to break anything, it's just going to add new information rather than removing it. So the obvious next question is, okay, well, how do I remove J from master? Because I don't want that to be there. To do that, we're going to move on to another command called git reset. Now what reset does is it allows you to modify this branch pointer. So up here, what I'm doing is I'm saying I want to go back to the master branch, and then I'm going to run git reset -- hard head tilde. Now there's a couple of things going on here. The first thing is this head reference in all capital letters. Head means whatever commit I'm currently sitting on. So again, if I'm on master, then head means the tip of master. When you add little modifiers after it, you can tell Git to climb up the parent tree to find other commits in that ancestry. So head tilde means the parent of the commit I'm currently sitting on. Head tilde is the commit's grandparent, and so on. You can add as many tildes as you want to after that reference head. So then there's the rest of the commit, git reset -- hard. There are lots of different ways that you can use resets. And the way that you modify it, whether it's normal reset, hard reset, soft reset, is going to modify how the files on disk are changed independent of sort of the graph of commits that Git knows about. So you can do a soft reset and it'll leave the files on disk exactly how they are, but undo the commit reference. And then when you run git status, you'll see all those changes on disk just as though you had never committed them. So in this case, we're doing git reset dash dash hard head tilde to indicate I want to modify the master branch pointer to point to the commit that was the parent of whatever commit is currently on there. So as you can see, the branch pointer is now pointing at F instead of J, and the J commit is still there. If you have the commit hash for J, you can still reference it. You can still check it out. You can still run git show with that hash. It's all still in the repository. But Git has its own internal garbage collector. Yes, it's that complicated. It has its own garbage collector. That sort of blew my mind when I found that out. And at a certain point, when you have enough commits all sort of stored in Git that the repository size gets big enough, that garbage collector will run, and it'll find any commits that aren't referenced anywhere, and it'll clean them up. But again, it's not going to do that immediately. So if you make a mistake with reset, as long as you have that commit hash, you can undo it. You can go back to the way that you were. And we're going to go over how to do that in a bit. So that's reset. Next is rebase, which is the command that probably a lot of you have heard about and been a little bit scared about. Rebase is the command for changing history. Use its awesome power responsibly. And the reason why I say that is because when you're changing history on your own repository, that can be very useful to make it so that, for example, you undo mistakes, make it so that you never made this mistake in the first place. But for someone else trying to interact with you on your repository, it gets very confusing to see that all of a sudden this entire history has changed and I don't know what happened. I wasn't expecting this, so what do I do? And that's when you start getting some really weird errors from Git. So a couple of rules of thumb before I go into how to use rebase. Never change history when other people might be using your branch unless they know that you're doing so. So essentially what that means is if you're working on your own feature branch and you're not expecting anybody else to be looking at your commits, then you can rebase, you can change history as much as you want. But as soon as something merges to master, or as soon as other people might be looking at your branch, you don't want to be changing history. The second point sort of follows from the first. You don't want to change history on master because that's the branch that most people are going to be looking at and expecting it to have a consistent history. Best practice is only change history for commits that have not yet been pushed. What that means is if I'm part of a team and we're all maintaining our repository on github.com, and I have my local clone, which is on my computer, it's easy and trivial for me to change history for the commits that are still on my computer before I run git push. But once you run git push, those commits have gone out to github.com. Other people might see them. Other people might get confused if they go away. So this is sort of a best practice. It depends on you and your team for how you want to handle the workflow of changing history. Just talk with your team and ask them what they want to do. Worst case, you have someone else help you to fix your problem and to get back to the way things were before. So with all of those warnings and all of those caveats said, let's understand what rebase is and how to use it. So how many have been in this situation before? I'm working on a feature branch. There's been a lot of changes that have merged since then. I want to get those changes into my branch. A lot of people will use merge to do that, but the problem with using merge is that it introduces a whole bunch of merge commits into your branch history, which causes it to become more confusing, particularly if you're trying to view the commits on GitHub. Sometimes it gets sort of screwy. So I generally suggest using rebase instead. Here's an example, by the way, of what I was talking about. The feature branch was forked off at commit C, but since then, commits D, E, and F have all been added to master, and we basically want to get those branches, those commits into the branch. So this is what rebase actually does. It's basically a series of cherry picks. It's going to find the merge base, which is that one commit where your branch originally forked off of the main line of development, cherry picks all the commits since then onto the commit that you want to reference, and reassigns the branch pointer. So it's almost like you are picking up the branch, moving it upward, and dropping it down. You're finding a new base for the branch of development. That's why it's called rebase. I know the name is confusing for a lot of people, but when you look at it this way, it makes a lot more sense why it's named this way. So that's the concept. And once again, you're not actually destroying anything with Git. You are making new commits. And if you have a problem with your rebase, if something goes screwy and you want to undo it, you want to back out, those original commits are still there. And you can go back to the way things used to be, and nothing's changed. Rebase isn't going to break anything. It's only going to reassign some pointers. And if you get confused, you can just reassign those pointers back to the way they used to be. So how do we actually do that? Here's an example of running git rebase to solve that problem that we saw before. I'm going to check out my feature branch, and then I'm going to run git rebase with a reference to the commit that I want to rebase my branch on top of. And you can see Git's going to tell you some messages saying, all right, I'm going to rewind the head. We saw that head is a reference to whatever pointer you're currently sitting on, and replay your work on top of it. And those applying lines are just where it's making the new commits using cherry pick one at a time. And if you have something that looks like this, it's a successful rebase. Now, here's the thing. As I said, changing history is something that is not done lightly. And when you do this, and then you run git status, you're going to start getting some odd messages. You're going to see your branch and origin/feature have diverged and have 6 and 3 different commits, respectively. So what does that actually mean? Like, if you've ever seen this message before and been really confused, what does a branch divergence mean? It sounds like a movie. This is essentially how the 2 different repositories look at this point in time. You have a repository on GitHub, which is the remote, which has the branch as it was. And then you have the repository on your local computer, which is after the rebase. And you can see that there's no way to go forward from I to I prime. In order to get from I to I prime, you essentially sort of have to go backwards. So down here and then up to try to get back to that other one. So Git gets confused because it doesn't want to go backwards through history normally. So that's why it complains. And then if you try to push, it's not going to let you do that by default either, because it's telling you that there's no, I'm sorry, let me read my slide. Updates were rejected because the tip of your current branch is behind its remote counterpart. So that's basically saying there are commits in there that I didn't expect, and it's running behind, and it looks like there's been a change in history, and I'm not sure if you want me to do that. However, it's going to allow you to force push to say, yes, I know that we're changing history, but I actually want to modify the branch pointers in this way. So you can see that Git allows you to modify history in order to do these really nifty things, like making it appear like your development happened after these new commits that have merged into master, but it's careful about allowing you to do that. And in fact, even when you run this, it's even telling you this is a forced update. Even when you force push, it's going to let you know, I'm doing this under duress, I'm doing this because you specifically told me to, I'm changing history, be aware of that. So Git does give you the power to change history, but it's careful, and it tries to help you to avoid making mistakes accidentally. So the next thing, some of you may have seen merge conflicts when trying to merge branches in. You can actually get rebase conflicts as well. This is an example of trying to run git rebase and finding that in trying to replay those commits on top of the new commit, things didn't actually work out quite so cleanly. And it'll actually say there's a merge conflict going on in here. And then after you've run this, you can again run git status to figure out what the heck is going on. And it's going to tell you there's a rebase in progress. We're rebasing this branch onto, and it's going to show you the commit that you're trying to rebase onto. And it's even giving you some helpful status messages. And it's telling you exactly which file both sides have modified. And then if you're familiar with a merge conflict, we're going to resolve this exactly the same way. So you open up the file in your editor, and you see those little carets with the head and equal sign in the middle and opposite carets the other side. It looks exactly like a merge conflict. And you can treat it exactly the same way. So you resolve the conflict, and then you re-add the file. But it does say that the resolution is different. So if you take a look at the top, after you've run git add, you can see it says to fix conflicts and then run git rebase -- continue. You don't want to make a new commit. Normally when you're doing a merge, if you have a merge conflict, you do git add and then git commit. With rebase, it's going to handle making the commit for you. But fortunately, as I said, it tells you that in the status message. So if you get confused about the proper thing to do, first instinct, always run git status. Just always. It gives you great information. In addition, If there's a problem with resolving the conflict, you're not really sure how to resolve it properly, you can always just run git rebase -- abort. And what that will do is it'll set the branch pointer back to your original set of commits and basically make it like you never even tried to do the rebase. It'll fix everything for you, which is great. Another thing to point out is because a rebase is just a series of cherry picks, technically that means that you can get conflicts when running cherry pick as well. So if I run git cherry pick and pass it that hash, you might get an error that looks like this. And once again, git status is your friend. You can run status and it'll tell you exactly which files are in conflict. When you're done, you resolve them and you run git cherry pick -- continue. Or if trying to resolve that isn't really worth the trouble, then you run git cherry pick -- abort. Exactly the same thing as rebase. Again, all of these things are right in git status. It's trying to help you. It's giving you the information right there. So that was rebase with a quick throwback back to cherry pick. Next thing I'm going to talk about is the reflog, which is going to save your ass if you're ever modifying history. So git log is probably a command you're already familiar with. It's showing you commits in ancestor order. So you started a commit and you go parent, 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 all the way down. Reflog is similar, but it's showing you commits in the order from which you last referenced them. So you're looking at this slide and you're seeing all these arrows all over the place and you're thinking to yourself, I have no idea what that means. So let me show you an example of when you might want to use this and how you actually do so. So you would use the reflog when you have a problem with Git, particularly if you have a problem with changing history. And you want to go back to the way things before. And you know that you can use git reset -- hard if you have the commit hash, but you don't have the commit hash. You lost it. You didn't write it down. Reflog will help you out. Reflog will save your ass. So if I run git reflog, what it's going to do is it's going to show me all the operations that I've been doing lately in order, in chronological order. So if I take a look at this, I can see that the last few operations I've done on this repository is I tried to do a rebase and I aborted it. And before that, I made a new commit. And before that, I checked out between a couple of different branches and I tried to get to a different commit, which has that commit hash that starts with DB. And before that, I did another rebase, but this one was successful. And you can see every single commit that was added before it. And at every line, you can see in that first column the short hash of the commit that it's referring to. So what that means is, let's say I did that rebase, and now after I've done all these operations, I realize, oh no, I didn't actually want to do that rebase at all. I want to go back to the way things used to be. I want to undo the rebase and just go back to the original version of the branch. Well, what I can do is I can find that commit hash and then check out the commit, take a look at the files, make sure that it really is what you expect it to be, and then use git reset to set the branch pointer back to that commit. And everything's exactly as it used to be. So again, if I didn't mean to rebase that feature branch, I can find the commit from before the rebase and then do git reset -- hard to say, actually, move that pointer to point back to the commit that it used to point to. And then everything will be hunky-dory. So we've learned how to rebase. We've learned how to use reflog to recover from a bad rebase, which should give you some confidence so that you can do so knowing that you're not going to screw up. Now let's see what you can do with rebase that makes it really powerful. How many have been in this situation before? I just made a commit, I forgot to include a file, the tests don't pass, it just doesn't work. Now most people, when they do that, will just immediately make a new commit with a message like, oops, I forgot the file, and it makes you look a little bit silly. But what you can do is you can actually modify history and squash them together. So the simplest way of doing that is to use git commit -- amend. And what that will do is it'll take the changes that you've added and it'll make a new commit that rolls together your most recent commit and those changes. It replaces the most recent commit with that new commit. So you are technically modifying history here, but this is another case of you probably haven't pushed this commit yet. You just ran git add, git commit, and then you realize the moment after you hit enter after pressing git commit, oh, oops, I needed that file. So you can just use git commit -- amend. And this is actually taking the old commit off the history, making a new one, plopping it on. But as long as you haven't pushed yet, you don't have to worry about it. Now, let's say you have a lot of these. Let's say you've made like 5 different commits where you forgot to add files, or you realize that the test broke and you need to fix the test to get it to work. So this time we're going to break out the big guns, and we're going to do interactive rebase, which is just as awesome as it sounds. So what does this mean? To do interactive rebase, we're going to tell Git to take a look at a certain number of commits and do some operations on them that we tell them. So in this case, we're going to say that we want to start 5 commits back, and we want to do certain rebase operations to change history, starting with the last 5 commits. Now in this case, I'm saying git rebase -- interactive head ~5, which, by the way, the head ~5 is another shortcut. Remember how I said you can add as many tildes as you want after the head reference? If you say head ~5, that's just a shortcut for saying 5 tildes. You can do head ~10, and that means 10 tildes, and so on. So again, you don't have to type quite as much, which is great. So when you run this, Git is actually going to open a file in your text editor, and it's going to use that file as a user interface, which is kind of cool. So this is how it looks. You have at the top those last 5 commits, and you can see the messages that you have there. So you can see that commit 1 and commit 2 are sort of reasonable commits, but commit 3 and 4 are both commits that maybe we didn't intend to be an entire commit. They really should be sort of rolled into commit 2. And then that last commit at the bottom is a commit that we also want to keep separate. So really what we want to do is we want to take those 3 in the middle and squash them down into 1 to make it appear that we never made a mistake. Because it's great. When you can change history, you can make everyone think that you're a perfect coder. It's awesome. So what we have here, as I said, is actually a user interface. And you can see we have a list of commits going down the side. At the bottom, we have a set of instructions. And on the left side, we have a set of actions for each commit. And you can see at the bottom, the default action is pick, or just P. It says use the commit, don't make any changes to it. That's just like cherry picking the commit, exactly like we were doing with a non-interactive rebase. In this case, what we want to do is we want to use that squash command. Use commit, but meld into previous commit. So as I said, this is in your text editor, and you can edit text in a text editor. So if you want to tell Git to do that, you just modify those 2 picks and literally write in the word squash. And then you save and quit your editor, and it's going to immediately reopen your editor with a different file. And this file has all of those commit messages from all of those different commits that you're squashing together. And now Git is giving you an opportunity to write a new message for your single squash commit, which might just be your original commit message from the one that you intended. It might be something different, might be something you want to modify, and so on. And then save and quit, and Git will apply your changes, and history has been changed. And you have no more of those oops, fixed a typo, or oops, forgot to add a file commits. You look like you did it right the first time, which is amazing. And as a reminder, squashing commits does change history. So all of those other warnings that I talked about still apply, with making sure that if you're changing history, other people are aware of it, and they know how to handle that. Now similarly, what if my commit is too big? And I want to pull it apart into several smaller ones. Maybe I was trying to work on this one feature, but while I was in the process of doing that, I discovered, oh, there's a bug here. I'll just fix the bug. And then you roll all of that into the same commit, when really the bug fix should be in one commit, and the new feature should be in a separate commit. So once again, we're going to use git rebase interactive. So here we're going to look at 3 commits, and you can see that one in the middle is maybe a little bit too big. There's a bunch of things that we did, and it's sort of, ambiguous exactly what that commit is supposed to accomplish. So if we want to split that commit into pieces, we can use a different command. We can use the edit command. So again, just changing the word pick to the word edit, and that's going to use the commit but stop from ending. So you save and you quit, and then it's going to pause in the rebase process at that point that you've asked to edit, and give you as much time as you want to create some new commits. So this is a time when you can do git add and git commit to sort of take your changes, because they're on your file system at this point but not committed, and pull them apart into several smaller commits. And then when you've made those smaller commits, you can run git rebase -- continue, and it'll continue applying the rest of the commits in that sequence that you specified. So it's going to, by default, have that commit applied. So you can use git reset head tilde. Notice I'm not using the -- hard, so that's going to keep the changes on your file system so that you can then add them one file at a time or piecemeal to make those commits that you want. Then you can use git status to take a look at the files that you have. And I guess I added slides for these without remembering. You add them one at a time, make your own different commits. So this is the smaller commits that I'm talking about. And then when you're done, git rebase -- continue. And you can take a look at your history and admire how nice it all looks. So we are almost done. There's one section left, which is perfect because I'm running out of time. Git bisect is a really, really cool feature of having a clean history. How many have been in this situation before? Master's broken. We don't know when master broke. We're so confused. How did this happen? How is this ever working? Bisect is going to help you to find the commit that introduced that problem, which, by the way, is a reason why you'd want to have a nice clean history with small commits that are focused on individual pieces. If you can identify which of these two commits caused the problem, then it's helpful to take larger commits and pull them apart so that that helps you find the problem. So what bisect does is it allows you to use binary search to find the commit where things went from good to bad. So to use this, you need a test to determine if things are broken, you need a commit where things were working, and you need a commit where things are broken. And it's just going to check out various different commits and run that test on them. So here's an example of how you do that. You say git bisect start to say we want to go into bisect mode. Find the broken commit, tell it that it's bad. Find the working commit, tell it that it's good. And then, as I said, we're going to use binary search to check out the commit in between. If that commit in between that bisect has done for you is working, you tell it that. If it's broken, you say git bisect bad. Either way, it's going to use that to find the next commit. So another visualization. Here's where we are. We have a broken commit, we have a working commit, and Git has checked out that commit in the middle. Is it good or bad? If it's broken, we know that we can chop off half of all of those commits. And if it's working, we can chop off the other half. And either way, just keep on going recursively. And you can very, very quickly find that commit that caused the problem. If you have an automated test, it gets even better. You can just run that automated test by doing git bisect run mytest.sh. And Git will just do this process for you, just ramping through. It's going to check out the commit, test it, check out a new commit, test it, check out a new commit, test it. And in just a couple of seconds, you'll find the exact commit that caused that bug on production and save your bacon really, really quickly. So that's my presentation. There is still way more of Git to learn. There's a whole lot of cool stuff in there. If you want more help, Git has an integrated help system, so you can run, for example, git help rebase, and it'll help you out with that. The Git website has some good documentation. GitHub has some great docs. In addition, if you like the way that I explain this, I'm actually writing a book about Git. And it's going to be published by O'Reilly. If you're familiar with the Head First series, it's a lot of fun. So if you're interested in that, you should go to this shiny little URL right here. And there's a mailing list that you can sign up for, and I will send you an email when the book is available for purchase, because I am not yet done writing it. But here is all the stuff that we went over. We did blame, cherry pick, reset, rebase, reflog, squash, split, bisect. And the link to the slides is right here if you want to use them as a reference. That's my name. That's my handle on Twitter and GitHub and everywhere. Any questions?
Which one do you like?
All right. Question 1, will tab completion complete a git commit hash? That is a very good question, and that is something that is actually not built into Git, but is going to be dependent on the shell that you're using. So most people use a shell called bash, which does not have Git integration by default. I usually suggest that people use a different shell called ZSH or Zesh. And there's actually a framework called OhmyZSH, which has a whole bunch of good stuff baked into it. And if you use that framework, then yes, you can get Git tab completion, not just for commit hashes, but for commands, for branch names, for tags. It's fantastic. ZSH. Z as in zebra. Yeah, ZSH. So you can get that same sort of integration done for bash as well if you want. However, it's usually really just easiest to use ZSH because it's all baked in very easily, so I highly recommend that. How is cherry pick different from git diff and then patch? It's automated, basically. When you use git diff, you can find the changes that you have on disk. You can also use git show to find the changes that are in a commit. And then you can take those changes and you can make a new commit that has exactly those same changes in it. However, it depends on if you really want just the changes or if you want the metadata as well. Cherry pick is going to preserve authorship information, and it's going to preserve any other metadata that might be applied to it as well. So it's actually a cleaner way of doing it, and it's way simpler as well. Can I bisect on this? And there's a diagram here with several different commits in here, two of which are highlighted. I assume that that means that there's two commits that you're trying to find where maybe one of them causes one problem and the other causes the other problem. To do that, you would just do two different bisects. You have one known good, one known bad commit, and it just depends on what test you're running. One test is going to find whichever one commit caused that failure. So you would just do it twice. When would you rebase rather than merge updates into the feature branch? Typically, I rebase rather than merge when the updates that I'm pulling into the branch aren't related to the work that I'm trying to accomplish in the feature branch. So let's say I'm trying to add a new feature to the authentication system of my website, and someone else has merged in a major refactor that changes how all the automated tests are running, maybe makes them a heck of a lot faster or something like that. Those two things are totally independent of each other. And it doesn't really make a whole lot of sense to my mind to merge the former into the latter, because that just means you have one branch that does a whole bunch of things that aren't related to each other. So that's a case where I would use rebase. However, if I'm working on a feature branch that adds features to the authentication system and someone else has a feature branch that fixes a bug in the authentication system, maybe I'd want to merge that bug fix into my feature branch, because that seems related. Because then the branch that you have at the end still has everything put together. On the other hand, maybe you just want to cherry pick that one commit in. It's up to you. Git is very much a case of many ways to skin a cat, or many ways to accomplish the same thing. And there's actually a whole book by Emma Jane Westby about Git workflows with your team. And it's really just something that you should decide on with the other people that are using Git about when to use rebase, when to use merge, when to change history, and so on. When I rebase and the first commit in my feature branch conflicts with master, I have to resolve the conflict for every commit in my feature branch. How can I do this better? That is an excellent question. There is a really nice feature built into Git called re. Stands for reuse rebase resolution, I want to say. I might be getting that acronym wrong, but it's R-E-R-E-R-E. It's not a command that you run, it's actually a configuration setting. So you can turn on re in your config file. I recommend that you search Google for it or something like that. If you have that turned on, what it will do is every time you resolve a conflict, Git will remember the resolution of that conflict. And when you're applying commits one after another, it's going to check, is this conflict that I know how to resolve? And if it knows how to resolve it, it's just going to automatically apply the resolution. So the reason why it's off by default is because it's really magical, right? When you think about it, it's, there's a conflict here, and your system is saying, I know how to resolve this, and maybe the system's wrong. maybe it thinks it has the right resolution, but it doesn't actually. And so in the interest of making sure that the developer has full control over what's going on with Git, that's turned off by default. But particularly if you're doing one of these rebases of a long branch with a lot of commits, maybe you want to turn that on ahead of time so that you only have to resolve the resolution once. Another option, if you want, is you could take all of those commits and you could squash them together first into one commit, and then just move that one commit on top. It depends on if you want to keep your commit history or not. If you don't really care about your commit history because maybe you're still in the process of developing, then maybe squashing first is easier. It's really up to you. Again, it's up to you and your team. And that is all the questions. So unless anyone else has anything else, you can raise your hand if you'd like.
Is there a way to do squash without rebase? It seems like we kind of want to use squash.
Squashing, the question is there a way to do squash without using rebase? And the only instance I can think of for that is that git commit -- amend that I talked about. What you're doing there is you're essentially taking your existing changes and squashing them into the commit that you have most recently. But if you want to do anything other than that, you are actually changing history. You are changing the list of commits that you have in your history. And if someone else tries to view the history, even if the diff is the same, maybe the author has changed, maybe the date has changed, maybe the commit message has changed. So no, the only way to do squash is to change history, and the best way to change history is to use rebase. I'm not aware of any other ways. Anyone else? Yeah, I think we're all set. So thank you all for coming.